Okay, and here we are for the video for 4.2, translations of the graphs of sine and cosine functions. This is going to be one video. I'm hoping, there's only 6 examples, so I'm hoping that we can get it done in a 25 to 30 minute period, because they have 2 things going on, but they have them going on at the same time. So 4.2, translations of the graphs of the sine and cosine functions. You're going to graph sine and cosine functions that have translated equations. Anyways, you're going to be moving your starting point left or right, or you're going to move the whole graph up or down. So translations, go back to geometry thing, translations. Just the same old thing, it's moved. Shape doesn't change, it just gets moved. Okay, so let's talk about horizontal translations. This is called a phase shift. So when you see phase shift, they're talking about it being moved left and right. The graph of the function defined by y equals, sorry, I didn't get my pen ready. By y equals f of x minus d is translated horizontally compared to the graph of y equals f of x. The translation is d units to the right if d is greater than 0, and absolute value d units to the left if d is less than 0. So again, we're not going to graph these. You guys can go back to that web page and play with it if you wanted to see what these are looking like. But I need to throw this out there. Keep in mind this is x minus d. So if I have x minus pi, then I'm only looking at the pi, and it is greater than 0, so it's going to be moved to the right pi times, or 180 degrees. This one, x minus, is a negative pi over 2. So this is the guy we're looking at. This is no different than in algebra when we did this in algebra. So this is less than 0, so you move it left pi over 2, or 90 degrees. Patterns don't change. It's just all you're doing is changing where you're actually starting the pattern. Okay, vertical translations. This is going to be on the outside. The graph of a function of the form y equals c plus f of x is translated vertically as compared with the graph of y equals f of x. The translation is c units up if c is greater than 0, and absolute value is c units down if c is less than 0. Don't know why this got cut off over here, but it did. So y equals sine of x, again, we're not going to graph these, but this one here will have simply been moved up 2, and this one here, and we're talking the entire graph. This one would have been moved down 2. And we're talking entire graph, not just the points. So we're adding, this one we would add 2 to all of those pattern points. This one we would subtract 2 from all of the pattern points. So I want you guys going back to 4.1. Nothing's changed except for on the vertical translations is once we have the pattern, we'll either move it up or down. This one here, we have to identify the values. So the phase shift, you have to identify your beginning endpoints, and then you throw the patterns onto those beginning endpoints. Okay, now I kind of went crazy on these because I don't follow these steps. The graph y equals c plus a times sine of b times x minus d, or cosine. Follow these steps. Now, the computer program that we were using, they had c and d interchanged. They had c inside and they had d on the outside, if I remember right. Okay, we're definitely going to do this first step here. Find an interval whose length is 1 period, 2 pi over b, by solving the 3-part inequality. There it is. I'm not going to worry about you guys identifying b. B is going to be the number in front of x. It will affect your d if it's inside the parentheses. So I do need to throw that out there. So we'll just, it doesn't matter where b is, we'll still do this. Okay, divide the interval into, I said 2 equal parts, and then tally your quarter points. So still your interval into 4 points. You are not going to make a table of values on these. It says plot the points found, that's where I said we're going to use the pattern A times pattern plus C. When the problem asks for a 2-point period interval, draw 1 period in one direction and the other in the other. So one in the positive direction, one in the negative direction. Anyways, if you're going crazy with the steps, I'm going to throw them out there and I will try to do every problem exactly the same so there's no difference on these. Okay, so the first one, find the amplitude, the period, any vertical translation, and any phase shift of the graph of each function. So you're just going to go through and identify, well, A equals, A is what's being multiplied in front, as a reminder, 2 over 3. Your B value is in after sign, but in front of X, so it's 1. So from here, we can find our period, which is 2 pi over 1, or simply 2 pi. Our C value is what's being added to the end. There's nothing there, so it's 0. And D is what comes after the X that's being added. It is negative pi over 2. Because remember, it's X minus D. And since this guy is positive, we had to make it became X minus negative pi over 2. Or 90 degrees. Okay, so this is our phase shift, negative pi over 2, so negative 90, which means it's going to get moved to the left. So when we come to this one here, this is where it's going to be really kind of difficult to throw in those intervals, so you might have to actually do it. All of our intervals are going to be 90 degrees. So remember, 90 degrees is negative pi over 2. So negative pi over 2, 0, pi over 2, 2 pi over 2, 3 pi over 2. And I just realized I didn't go through with you guys finding the beginning any points. So how do you know where to stop? Well, that's where the 0 is less than or equal to x plus 90. We're going to go ahead and do it with degrees. Is less than or equal, and 2 pi is 360. Okay, so those of you who are going to go, wait, where are these numbers coming from? A full rotation is 0 to 360 degrees. But I'm changing some things, so I have to identify where this rotation actually started. So that's where this comes in. So I'm going to subtract 90 from all three parts. So I get negative 90 is less than or equal to x, which is less than or equal to 270. These are degrees, so I'll put the degree symbols. But I also know that this is negative pi over 2, and this is 3 pi over 2. And yes, you should know that as well, because that's off the unit circle. So there it is, negative pi over 2 to 3 pi over 2. The halfway point is going to be positive pi over 2. And then our quarter points, believe it or not, your quarter point here is at 0 and at pi. So 1, 2, 3, 4, 5 points. I have 5 points. And I have to throw, and it just says, it doesn't say to graph it over 2, so we're just graphing it over 1. People forget that 0's there. I don't know why, but they do. This is 0. I'm going in terms of 90 degrees. So remember, you have to identify your halfway points. There it is, pi over 2. And then 3 pi over 2. If you have to, use your unit circle to identify where things are at. Okay, so we need to do A times the pattern plus C, but our C value is 0. So it's 2/3 times our sine pattern of 0, 1, 0, negative 1, 0, plus 0, so we don't have to worry about that guy. So we're going to graph the points 0, 2/3, 0, negative 2/3, 0. So 2/3, 1, 2, 3. There's 1. And 1, 2, 3. There's negative 1. Sine starts at 0, so we're at 0. And then we're going to go to positive 2/3, back to 0, down to negative 2/3, and back to 0. And we try our best to make a nice smooth curve through our points. And there's your sine wave. A lot going on. I get it, there's a lot going on. And if I was to grab those steps, I would tell you identify A, B, C, and D, the period, your beginning and end point, and then your points of the graph. And then go back to your graph and actually put those in. Beginning point, end point, halfway point, throw in the quarter point. And if it's kind of shifted to the side and you're going, I don't know where it is, then you just kind of figure out going, well, if it's beginning with pi over 2, ends with pi over 2 kind of thing, then you can kind of play with it, do those in those intervals and then just calculate where you're at. You're not going to get very many where they're not going to play nice. Okay, let's try our next one. Okay, find the amplitude, period, any vertical translation, any phase shift to the graph. So A equals 1/2. Now where's the guy here? B equals 2. Always in front there. So that gives me a period of 2 pi over 2 or just pi. We've got a nice horizontal shrink going on here because my one length of to get the graph going is going to be pi. My C value is in front being added or subtracted, so -1. And the D value is in the parentheses. But you can't take 3 pi. You have to take the 3 divided by the B value. So when it's in here, your D value is going to be, your D value will be whatever is behind the plus minus divided by your B value. So this is going to be 3 pi over 2. Okay, so let's find our beginning ending points. So this is going to be 0 is less than or equal to 2x minus 3 pi. But to make life easier on us, let's go ahead and make this one in degrees so that we can do these. And this one is 540. So 540 degrees less than or equal to, and then it's always 2 pi, so 360. Add 540, add 540, add 540. We get 540 degrees is less than or equal to 2x, which is less than or equal to, I believe that's going to be 900. And then go through and divide everything by 2. So we're going to get 270 degrees is less than or equal to x, which is less than or equal to 450 degrees. Do go back and change these guys into radians before you throw them on the graphs. So this is 3 pi over 2, and 450 degrees is 5 pi over 2. Now, when graphing, this is where you have to be really, really careful with what you're graphing, because you can't just say, okay, here's 270 degrees. No, you still have to space everything nicely. And since these guys are in terms of 90 degrees, that's what we're going to do. So this will be 1 pi over 2, 2 pi over 2, 3 pi over 2, which is where we're starting, 4 pi over 2, and 5 pi over 2. My one just went a little bit too far to the right, so oh, they're all connected. Great. Well, we'll just deal. No, I'll erase. That one's too close to the others. And remember, you have to identify your middle point. Well, that's an easy one. 3 plus 5 is 8. Divided by 2 is 4. So it's 4 pi over 2. And 4 pi over 2 is just simply 2 pi. Quarter point. Quarter point. Be really, really cautious here. because this is the only part that you're graphing, is from 3 pi over 2 to 5 pi over 2. Nothing over here. Okay, so now we need A times the pattern plus C. A is 1/2. It's cosine, so it's 1, 0, negative 1, 0, 1, plus our C value, which is negative 1. So this is going to be 1/2, 0, negative 1/2, 0, 1/2. And now we have to take all of these and subtract 1 off of it. So 1/2 minus 1 is negative 1/2, negative 1, negative 3/2, negative 1, and then negative 1/2. Notice all of our values are negative, so we're always going to be below the x-axis on this one. So I don't need to label anything above it, just below. So we have negative 1/2, negative 1, negative 3/2. So I'm going to throw negative 1 here. And we start plotting our points. Now, because I'm going to do this only because my graph is all below the x-axis, I'm going to move all of my angles values above the x-axis. Unfortunately, I can't just move them because they seem to be attached. See? So I'm just going to erase the values and then rewrite them above. Yes, I saw it take my quarter points away. So 3 pi over 2, 2 pi, 5 pi over 2. So at 3 pi over 2, I'm at negative 1/2. And then negative 1, negative 3/2, back to negative 1, and then negative 1/2. And very squished in here, I know, is my graph, and that does not look like it should. It's so bad that it bothers me. And I didn't do any better on that one. I'll take too long just trying to get my graph to look the way I want it to look like. Oh, that's much better. Okay, so we've done, I think, 2 examples in a 15-minute video, but we're going to continue on these. And you know, you might get through going 2 or 3 examples, going, I'm done, I got it, I know what to do. So let's make sure we do at least one more. I think we got a couple more in here. So we continue on. A equals 3, B equals 1. So the period is 2 pi, or 360 degrees. C equals 0, there is no C value. And D, remember, it's whatever your B value is, divide this by it, but it's 1, so 3 pi over 2. Remember, x minus is part of the function, you just got to take it off. And this one is 270 degrees. So let's do our phase shift. So if we look at our phase shift, that's going to be 0 is less than or equal to x minus 270 degrees, which is less than or equal to 360. Add 270 degrees. And we have 270 degrees is less than or equal to x, which is less than or equal to 630 degrees. And if I throw those into radian values, we're going from 3 pi over 2 to 7 pi over 2. Okay, so we have all of our values. We're ready to set it up, but because we have to start at 3 pi over 2, we're going to make intervals of pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2, which is my starting point, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. And without even trying, I got my midpoint and my 2/4 points. Why did this work so well? Because when we graph sine and cosine without any phase shift, we're always going from 0, we're going in 90-degree order. 0, 90, 180, 270, and so on. So because I didn't shrink this one way or the other, I can go in intervals of 90. Okay, so our pattern, so it's 3 times our pattern for sine, 0, 1, 0, -1, 0. So the actual points on my graph started right 3 again, don't need it yet. It is going to be 0, 3, 0, -3, 0. So set up my x values or my y values, 1, 2, 3, so there's 3. I also go down to -3, 1, 2, 3, -3. So I'm over here, starting at 0. Just don't forget that where you're starting at. If that's going to throw you off these other points over here, erase them after you get it set up. So 0, then up to 3, back to 0, down to -3, and back to 0. And then we do our best to get a nice curve going on here. Okay, so this video at this point is 22 minutes long. So what I'm going to do is I am going to end this one. I'm going to do a part 2 video if you need more examples. So it'll be on a need-be basis. Good luck on the homework. Oh, let me go ahead and give you that way if you're looking for the homework at the end. There it is. I have 3 more examples that we need to do.